Hello, and welcome to Remedy Asset Relationship CBT, Computer-Based Training. Introduction to Asset Relationships and Terminology. The first slide that we will cover is what is a relationship. An asset relationship is the mapping of assets such as databases to servers, servers to applications, and ultimately to the provision of services. What is important about assets that are related in Remedy is that if something goes wrong with one of our assets, say this server in the middle, and we have a problem with the server, if the assets are properly related in Remedy, then we will know which database may be affected, we will know which application may be affected, and most importantly, we will know which people that are relying upon those services will be affected. Okay, a little bit more on the importance of relationships. Properly constructed asset relationships help us to determine the impact that failures or incidents have on our infrastructure, which is quite important. Relationships also help us determine the root cause of problems, as you saw in that previous slide. If there's a problem with the server, we can also investigate. By having the assets properly related, we can find what the root cause of the problem is, where that fire is starting from. Properly constructed relationships help us respond to incidents in a more targeted and efficient manner. Properly constructed relationships help us achieve quicker resolution times. So the bottom line here is about customer service and the provision of services. Accurate relationships lead to more reliable IT service. Okay, before we go on, I'm just going to touch briefly on configuration management. This is the ITIL discipline that provides infrastructure control via the management of asset configurations, their versions, and relationships in CMDB. So configuration management is a core ITIL discipline and a foundation for other important disciplines. So, here at DoIT, some of the top disciplines, the top 3 ITIL disciplines in use are asset management, change management, and incident management. What is central to all 3 of these services, asset, change, incident, is the CMDB. And the CMDB, we know what DB stands for. The CM part of the CMDB is configuration management. So by having properly related assets, we have a more effective CMDB. By having a more effective CMDB, the other ITIL disciplines such as asset, change, and incident management are more effective. Okay, just a little note on configuration management. We're going to refer through this presentation about assets or CIs. An asset that has been configured, that has configurations that are specific to the DoIT and DoIT's infrastructure. Once a generic asset has been configured, it is now known as a CI, or a configuration item. So that's an important term to note later on in case maybe there is a quiz. Okay, asset relationship chains. Assets that are related together can be thought of as chained together. And there's the old saying, a chain is only as strong as its weakest link. So let's just say this asset here that is represented by this chain link is undergoing a change. So we know the asset is going to be down. The request is submitted and the asset is related, right? So we know that it will be temporarily down. However, if that asset is not correctly related to other assets that depend on it to work, we will not understand the full impact of that change request and what other assets like this one may be affected if that chain is broken, if they are not linked together. So that's why another reason why it is important to have the proper relationships in Remedy. Okay, so let's cover the basics here. You need 2 assets in order to make a relationship in Remedy. You can't just have one. You need to identify 2 assets and then you're ready to create a relationship. All right, so let's say, for example, we have server A and we have a router here. And if we go into Remedy and we create a relationship, if a user creates the relationship from that server A to router B, which we're going to indicate with this arrow right now, I want you to pay attention to the type of arrow. This is actually not the particular convention that we use. This is just showing that the server A has been related to router B. So what that means is automatically in Remedy, router B will be related to server A. So in other words, you don't have to do the item twice. The relationships are 2-sided. So if a user goes in and creates this relationship A to B, then if you just independently or maybe the next day search for that record B, the router B, when you look at that record, you will also see that relationship from B to A. So that's what those arrows are indicating. Again, that they're going to be different than the correct arrows we use for nomenclature. We're going to cover that in a little bit. The other piece here, a single asset can have multiple relationships. All right, so this is a key concept right here. So we have firewalls. Routers are usually connected to many items. So we have routers. You have a firewall hub switch. So there is just there is multiple relationships are possible. All right, now we're going to cover the relationship types in Remedy. There are 4: dependency, component, member of collection, and element location. Dependency describes separate assets that rely on each other in order to perform. So, for example, a program is dependent upon an application server. The app server is dependent on the database. Those are two items that are separate but dependent upon each other to work. And this right here makes up for approximately 80% of all relationships that are used in the DoIT CMDB. So the dependency relationship is very important, the most commonly used relationship. Next is component, and this makes up about 10% of all relationships in the CMDB. And the component, the way I like to think of this is if you think of your cell phone and then you think of the parts that make up your cell phone, the breadboard, the little transistors or whatnot are inside, those are components of. So a component relationship establishes part of relationships between two CIs. So a network card is a component of a computer system. There's a dependency there, but in this instance, these two assets, the asset is located within the other. So that's different than the previous example of an application server and then a database that may or may not be on that server. So those are the difference there between dependency and component. So that's what a component relationship is. Next, we have member of collection. This defines logical groupings of assets, kind of similar to a network topology. This relationship type helps us establish which assets are members of which collections. So, for example, a phone, fax, and voice over IP network, they may be members of a telecommunications collection. Here at DoIT, member of collection is often used to relate the assets that comprise the business services we offer. So, for example, the MS Exchange servers, clusters, and nodes, all of those assets are members of the DoIT Exchange 2010 collection. Another way of saying that is that the MS Exchange server is child-related to the DoIT Exchange 2010 business service. But more on child-parent relationships in the next slide. Element location relates CIs to physical location. If we were using it, say, this computer is located at 5 Metro Tech, but we actually do not use that in DoIT. So element location, not used at DoIT. All right, parent-child relationships. The following is defined for a dependency relationship. So each of these previous relationship types, they all have parent and child relationships, but the definitions change slightly for each one. But we're just going to focus on dependency now because that's the one that's mostly used, and that's really the core of this tutorial that we're giving here. So when one asset is declared dependent upon the other, what it means is the parent is the source of functionality that allows the child to operate. Okay, and the child operates because of this relationship and is therefore dependent on that parent asset. All right, so let's just take a look at this. If we have a basic computer, we're going to say this is a workstation, and we throw a monitor into the picture here. We have a workstation and a monitor, and let's connect these two guys with a wire. This is the RGA cable that is connecting the computer to the monitor. So I'm going to ask you to guess which one do you think is the parent and which one is the child. That's correct. If you guessed computer was the parent, because the child, which is the monitor, cannot function without the parent. Of course, if you plug the electricity into the monitor, some people will say, well, the monitor can turn on, but what good is a blank monitor with nothing to look at? So the monitor gets its information from the computer. So for all intent and purposes, the monitor is dependent upon the workstation. Now, again, this is just a very simplified example. We here at DoIT, we do not relate monitors to desktops, just as an aside. I'm just using this as a very basic example to teach the concept of parent and child. So when we throw the power source into the computer, now which one do you think is parent and child between the computer and the power source? So I would ask that question: can a computer function without the power source? And the answer to that is no. So then that makes the power source the parent and the computer itself the child. And actually, the UPS, the power source, is pretty much the top parent in all relationship diagrams here at DoIT, because basically everything that we have here, all of our infrastructure requires electricity to run. So that's going to be the top parent in relationships. All right. So continuing with the basics, there are so many assets here at DoIT. How do I know which assets I need to create relationships for? Well, each support group is responsible to build relationships for the assets that they manage. So there's a little bit of a gray area in this kind of rule of thumb here. Certain assets cross between two groups. So in order to help with this, the Remedy admin team has come up with group-specific relationship diagrams. And we're going to show a sample one at the end of this tutorial. And those diagrams will show, for that fuzzy area where assets kind of cross in between groups, you can refer to that diagram to help realize which assets that your group is responsible for. Okay, so asset relationship layers. This slide is a conceptual slide. It just goes to show you that if each group here at DoIT creates the relationships for the assets that they manage and follows the documentation for the assets that are in between, what happens. So I remember what I said. The top parent, a facility support group, they manage the UPSs, PDMs. And as we said, those would be a top parent. IT security goes across several areas, and security has firewalls, switches, network ports, and communication endpoints. Network support, switches, hubs, routers, etc. Windows Ops, servers, Exchange servers, OS. We have optical devices, Cisco ONS. Mainframe support, LPARS, ZLinux, Adabase, SNA, VTAM, CICS, DB2. These are sample assets there. Infrastructure engineering, they have virtual systems and IP endpoints that they're responsible for relating. SysEng, virtual machines, ESX hosts. Databases, virtual systems, virtual machine clusters. App infrastructure, we have Siebel, Windows, Unix. Database infrastructure, MS SQL, Oracle, and mainframe. And then rounding it out at the bottom, again, something that crosses many different groups, is storage and protection. Next, parent-child arrow convention. On the right-hand side is the relationship key. If you look to the top, it says child depends on parent, and the arrow is used to denote this, where the tail of the arrow is the child and the head of the arrow is the parent. So look to the arrow on the left, the big arrow. The tail denotes the child. So let's say I have a server, and server A is going to be related to a switch. So because it's the tail, server A is the child, and if the arrow head is pointing to the switch, that makes switch the parent. So just to pay attention to that convention when you see the round base of the tail and the head for the parent. All right, this is a DoIT group-specific relationship diagram sample. So if you look to the right side, there is that key. And this was actually one that we had created for System Engineering Group. And it shows the main support groups. We have the SysEng group in the middle. There are those ESXi hosts servers, so they're physical servers. And they are connecting to, we've created a vSphere cluster in this one, in this relationship diagram to represent the fact that on the right, all those virtual machines are connected to the ESXi hosts. However, it's a dynamic relationship, so it's constantly changing. So in any given moment, server 1 could be serving up information for that VM1, but then it could be server 2 for VM1. So it's very dynamic. So we have that vSphere cluster in the middle, and that kind of takes care of that. And then there's also a vSphere data center. You can see that red arrow is the component. Looking to the left, network support group. There's a switch and a hub that's connected, and just follow that arrow convention to know which one is parent, which one is child. And the last piece that I want to point out on the right here is relationships by group. You see there, so if there's a question as to what your group is responsible for, you will look for your relationship diagram. And on the right side, you can see which child and parent relationships syseng is responsible for, and we also denote some of the nearby groups like storage and network support, which relationships that group would be doing. Okay, so tips on building relationships. So they can be built in either direction, from parent to child or vice versa. But if there are many children to a single parent, it's more efficient to start from the parent, and then you can add multiple children at one sitting. So that's a little tip there for being a little efficient. And just this question, who creates relationships for assets that touch two groups? And we already covered that. That's to refer to the diagram that we had just looked at over here. All right, so we are ready to move on for the asset relationship fun quiz. So this is how the asset relationship fun quiz will work. I am going to read a description of one of the items that are listed below: component, configuration management, parent, member of collection. And once I read that item, you need to pick which one it is. You can write it down if you want. You can make a mental note, and then we'll tell you which one the answer is. Okay. So the first one is: this relationship type defines logical groupings of assets, such as in a network topology. Groupings. Groupings of assets. Did you get it right? Member of collection. Okay. Very good, if you got it right. Next question. This asset relationship type is not used at DOIT. So, which asset relationship type is not used at DOIT? That would be element location. Okay, very good. Pat yourself on the back if you got that one correct. All right, next one. An asset that has been configured to a specific use. So an asset that has been configured to a specific use. Do you know which one this is? If you said CI, configuration item, you are correct. All right, moving on. This relationship type describes separate assets that rely on each other to perform. Any idea? This relationship type describes separate assets that rely on each other to perform. And the answer there is dependency. If you said that, you are correct. All right, next question. The ITIL discipline that provides infrastructure control via the management of assets, configurations, versions, and relationships. Which one is the ITIL discipline? I'm sure this one is correct because it's very dissimilar to the others. And if you said configuration management, then you get a round of applause. All right. Okay, next question. This relationship type establishes part of relationships between any two assets. So when one asset is part of another asset, which one? If you said component, then you would be correct. All right. Final question of the day. When describing how a relationship is shared between two assets, this is the source of functionality that allows the other to operate. The source that allows the other to operate. Well, I'm not even going to give you the Jeopardy music on this one because I'm pretty sure most of you got this one correct. And if you said parent, then you are correct. And thank you for attending this tutorial.